Hi class, today our topic of discussion is logarithms. Now before I go into the definition of logarithm, in simple term I can say that logarithm is just another way to express an exponential form. What do I mean? Suppose you take any positive real number a and raise it to the power n, where n is a rational number, then a to the power n is equal to b. That's an exponential form. Am I correct? Where a not equal to 1. Okay, then this can be represented in logarithm form. How? This we can write as log of b to the base a, the base over here becomes the base over here, is equal to n. Whenever you write log, the base has to be there. If the base is not there, it becomes meaningless. Now based on the base, logarithm has two types. One is your natural logarithm and one is your common logarithm. Common logarithm. In common logarithm, we always take the base as 10. The base as 10. Okay, and whenever in the sum, if the base is not given, we know the base is 10. And in natural logarithm, we take the base as e, where e is a constant whose value is 2.71 approx. Okay, so the base has to be there. Now certain things, look over here carefully. What I told, a is any positive real number, which means a to the power n has to be positive always, which means b is positive, which means we wrote log b, which means log is defined only for real positive numbers. Log is defined for only real positive numbers. You don't have log of a negative number, which means suppose log of -2, suppose base is 3. It's not possible. Okay. Next thing I told you, a not equal to 1. The base cannot be 1. Why? Suppose I take log base 1, 2 equals to x. So this can be written in exponential form as 1 to the power x is 2, which is meaningless because 1 raised to the power anything will not give us 2, which means your log base cannot be 1. Your a cannot be 1. It can be a fraction, but it has to be a positive real number. Now, few more properties regarding this. Okay, look over here. Now look at this. Suppose a to the power 0 is equal to 1. We know, okay, in exponential form. And suppose if a not equal to 1, then this can be written in logarithmic form as log of 1 to the power to the base a is equal to 0. So log of 1 to any base except 1 will be 0. Second, see over here, we know a to the power 1 equals to a. So we can write log of a, base a, has to be 1. So if you're finding a log of a number with the same base, okay, then the value is 1. One more thing, log x, base a suppose, is equal to log, same base, y. We can say that x equals to y. You never cancel log. It's like sine theta, cos theta, where it's a one term, sine theta is one term. Similarly, log x is one term. You can't have like log 2 by log 3, then you are cancelling log. No, this is not possible. Okay, now how this came? Look over here. Number 3 I'm discussing. Suppose we take log this log y equals to n. Now in exponential form, can we write a to the power n equals to x? Similarly, when you compare these two in exponential form, can we write a to the power n equals to 1? So comparing these two, we can clearly write x equals to y. So if log x equals to log y with the same base, then we can say that x equals to y. Now we'll look at few sums based on these properties only. There are more properties which we'll discuss later. Now look at exercise 9.1 from L AGGARWAL. The first sum, you have to convert it into logarithmic form. They have given an exponential form. For example, 5 square equals to 25. So in log form, how we can write this? Log of 25, the base becomes 5, is equal to 2. Done. Let us see sum number 8. This is 81 to the power 3 by 4 is equal to 27. So we can write this in log form as log 27, and the base becomes 81 is equal to 3 by 4. So we converted exponential form to logarithmic form. Okay. Now look at sum number 2. 2 part 5 I'll do first. It's log of 32 base 8 is equal to 5 by 3. They've told us to convert to exponential form. So how can we write this? 8 to the power 5 by 3 is equal to 32. The base over here becomes the base for the exponential form. Okay. Look at one more sum. Sum number 6 is log 10 0.001 equals to minus 3. So how can we write this? 10 to the power minus 3 equals to 0.001. See, after calculation the value can be negative, but we can't find the log of a negative number. Two different things, okay? Now look at sum number 3. They have told by converting into exponential form, find the value. So 3 part 1, they said log 16 base 2. Now suppose this is x, we let. Then we can say in exponential form 2 to the power x equals to 16, which we can say 2 to the power x equals to 2 to the power 4, which implies x equals to 4. The bases are same, the powers are same. Okay. Look at next sum. This is number 5. Log of 0.01 and base is 10. Again, suppose this is x, you let. Then we can write this as 10 to the power x is equal to 0.01. Now this we can write 10 to the power x equals to 1 by 100, which is equal to 10 to the power minus 2. So comparing these two, we can say that x equals to minus 2. Done. Clear? Now we look at the next sum. Now look at sum number 4. Solve the following equation. They've given an equation. They've told us to solve it. Log of 25 base x is equal to 2. In exponential form, we can write as x square equals to 25. So we can write that x equals to plus minus 5. Now look carefully. X was the base, and base is always a positive number. Okay, not equal to 1, which means x will be 5. Minus 5 not possible, isn't it? Now we look at the next sum. It's 3 log x base 10 equals to minus 2. So simply we can write 10 to the power minus 2 equals to x, which means 1 by 10 square equals to x, which means x equals to 1 by 100. Okay, done. Or you can write as 0.01. Clear? Now look at 4 part 11. Log 0.001 equals to minus 3. Base is x. We can write in exponential form as x to the power minus 3 equals to 0.001, which means x to the power minus 3 we can write as 10 to the power minus 3, which means x equals to 10. Done. If the powers are same, the bases are also same in exponential form. Okay. Now look at sum number 12. This says log of x plus 1, the base is root 3, is equal to 2. So we can write this as root 3 square is equal to x plus 1, which means 3 equals to x plus 1, which means 3 minus 1, so x equals to 2. Okay, now look at the next sum. This is number 15. These are all 4. Okay, 4 has 18 parts. Okay, sum number 4. 4 part 15 log of x square minus 1 2 is equal to 3. Now we can write as 2 cube equals to x square minus 1, which means 8 equals to x square minus 1. 8 plus 1, 9 equals to x square, which means x equals to plus minus 3. Now both the values are possible, because if you put x as plus 3, you still get 9 minus 1, 8. Log of 8 is possible. If you put minus 3, again minus 3 square is 9, 9 minus 1 is again 8. Log of 8 is possible. So in this case x can be plus 3 as well as minus 3. Clear? Now look at sum number, this is 17th part, log 2x minus 3 equals to 1. They have not given the base. Common logarithm, we have to take the base as 10. So can I write 10 to the power 1 equals to 2x minus 3, which means 10 plus 3 equals to 2x, which means 13 by 2 equals to x. So x is 13 by 2. Clear? Now we look at the next sum. Look at sum number 5. Given log a base 10 equals to b, express 10 to the power 2b minus 3 in terms of a. Now look carefully. Log base 10 a is equal to b. Can we write this as 10 to the power b equals to a? Done. Now look, 10 to the power 2b minus 3. Can I write 10 to the power 2b by 10 cube? Which again I can write 10 to the power b whole square by 1000. Now 10 to the power b is what? A. So it becomes a square by 1000. So that's my answer. Done. Now we look at the next sum. Now look at sum number 6. Given log x base 10 is a, log y base 10 is b, log z base 10 is c. So from here we can say 10 to the power a equals to x. From here you can say 10 to the power b equals to y. And from the last one we can say 10 to the power c equals to z. Now look what they have asked. Express 10 to the power 2a minus 3 in terms of x. Now this can be written as 10 to the power 2a by 10 cube, which is 10 to the power a whole square by 1000. Now 10 to the power a is x, so we can write x square by 1000. Done. Number 2, you see they have asked 10 to the power 3b minus 1 to express in terms of y. So this we can write 10 to the power 3b by 10, which means 10 to the power b whole cube by 10, which is y cube by 10. Isn't it? Now look at the third part. If log p equals to 2a plus b by 2 minus 3c, express p in terms of x, y, z. Very easy. You can pause the video to copy this. Okay. Now see the third part I'm doing. We can write, see, it's given log 10 base p equals to 2a plus b by 2 minus 3c, which means this we can write as 10 to the power 2a plus b by 2 minus 3c equals to p, which exponent we have done already. 10 to the power 2a multiplied by 10 to the power b by 2 divided by 10 to the power 3c equals to p. Now look carefully. 10 to the power a is your x, so this becomes x square into, this becomes y to the power half, and this becomes z cube. We have already done. So your p is x square multiplied by y to the power half divided by z cube. Okay. Now we look at the next sum. Now look at sum number 7. If log x base 10 equals to a, log y base 10 equals to b, find xy. Very easy. From the first one, can I say 10 to the power a equals to x? From the second expression, can I tell 10 to the power b equals to y? multiply these two, so xy equals to 10 to the power a multiplied by 10 to the power b, so xy equals to 10 to the power a plus b. Done. Clear? Now we look at the next sum. Now look at sum number 8. Log a base 10 is m, log b base 10 is n. Express a cube by b square in terms of m and n. Easy. First, we can write from the first expression 10 to the power m equals to a. From here we can write 10 to the power n equals to b. Now look carefully, they have asked a cube by b square. And instead of a, I can write 10 to the power m whole cube. And instead of b, I can write 10 to the power n whole square. So this becomes 10 to the power what? 3m by 10 to the power 2n, which becomes 10 to the power 3m minus 2n. And that's my answer, okay? Now we look at the next sum. Now look at this sum, number 9. They have told us log x equals to 2a, log y equals to b by 2. Write 10 to the power a in terms of x. Very easy. Look at the first one. Log base 10 x equals to 2a. So can I write 10 to the power 2a equals to x? Which means can I write 10 to the power a whole square equals to x? Which means can I write 10 to the power a equals to root x? The square goes away. So root on the other side, it has to be positive, okay? It can't be negative. Look at the next one. Log y base 10 equals to b by 2. Express 10 to the power 2b plus 1 in terms of y. So can I write log of y base 10 equals to b by 2, which means can I write 10 to the power b by 2 equals to y. Squaring both sides, can I get 10 to the power b equals to y square? Look carefully. Okay. Then again squaring, okay. So 10 to the power 2b equals to y to the power 4. Why I have done this? Look carefully. 10 to the power 2b plus 1 equals to 10 to the power 2b multiplied by 10. 10 to the power 2b we got y to the power 4. So it becomes 10 y to the power 4. Is it clear? Now we'll do the next part. Third part. If log p equals to 3a minus 2b, express p in terms of x and y. Very easy. Look over here. Log p base 10 equals to 3a minus 2b. So can I write this as 10 to the power 3a minus 2b equals to p? Now this can be written as 10 to the power 3b by 10 to the power 2b, sorry, 10 to the power 3a by 10 to the power 2b equals to p. Now we know 10 to the power a is root x, so this will be root x whole cube, and 10 to the power 2b we know is y to the power 4. So this is my answer. This can be written as p equals to x to the power 3 by 2 y to the power 4. Clear? Now we look at the next sum. Now look at sum number 10. Log y they have given as x, base is 2. Log z to base 3 is x. Find 72 to the power x in terms of y and z. From the first one, log of y base 2 is x. Can I write 2 to the power x equals to y? Similarly over here, log z base 3 is x. So can I write 3 to the power x equals to z? Now look carefully. 72 to the power x. 72 can I write 8 into 9 to the power x. Now 8 can I write 2 cube, and 9 I can write 3 square. Now once you open the bracket, this becomes 2 to the power 3x multiplied by 3 to the power 2x, which I can write 2 to the power x whole cube, 3 to the power x whole square. So 2 to the power x is nothing but where we have written y. So this becomes y cube, and 3 to the power x is z. So this becomes z square. Okay. Now look at the last sum. Now look at sum number 11. If log x base 2 is a and log y base 5 is a, write 100 to the power 2a minus 1 in terms of x and y. Very simple. First, log x base 2 equals to a. Can I write 2 to the power a equals to x? Similarly, if you see this one, log base 5 y equals to a. So can I write 5 to the power a equals to y? I got this. Now they've asked for 100 to the power 2a minus 1. So this can be written as 100 to the power 2a by 100 exponential form. Okay. So this we can write 100 to the power, we can write this 100 square. No, 100. Now 100 we can write as 5 square multiplied by 2 square. Look carefully, 5 square is 25, 2 square is 4, 25 4 is 100. Now this, when you open the bracket, this becomes 5 to the power 4a multiplied by 2 to the power 4a by 100. Now 5 to the power a is y. So 5 to the power 4a becomes y to the power 4. 2 to the power a is x. So 2 to the power 4a becomes x to the power 4 by 100. And that's my answer. Okay. We'll look at the other properties of log in the next video. Okay.